Hello class, welcome to our first lesson dealing with section 4.6. We're going to go through all the different counting principles, some basics. You want to make sure that you know where your calculator is to plug some things in. So let's go ahead and get started with some of the counting principle ideas. The first one that we're going to look at is what's known as the fundamental counting principle, okay, or the fundamental counting rule. This essentially is saying you have a certain amount of ways to do one piece of information, a certain amount of ways to do another piece of information, and it's essentially just multiply them together. It's like an independent event type of idea. So it's just multiplying those two parts. For example, here it's like how many dinner options are there if there's 3 main courses, 4 side dishes, and 2 desserts. Well, it's just a 3 times 4 times 2 because there's 3 options for the first thing, 4 for the second, 2 for the third, and you just multiply those things together to get 24 different options. The fundamental counting rule is the base case for all types of probabilities with counting principles. Okay, so the base case is everything's independent, and I just multiply the pieces together, and that would be 24 ways that you can set up the dinner options, for example. And if you want the probability of getting one of those dinner options, it would be 1 out of that 24. The next thing we're going to do is look at arrangement of people or arrangement of objects in terms of if the order matters or doesn't matter. So the first thing that we need to make sure we understand is just arrangement of all groups. Okay, so if I take 3 people and say, how can you arrange them in a line? The first thing is, since you said arrange in a line, that means the order that you're placed does matter. That's something that you want to think about as you're looking at some of these questions. And what I like to do in these situations is put the 3 locations, like these are the 3 spots the people can stand. And this represents how many of the people could stand there. And so there's 3 people, so there's 3 options for the first. There's only 2 for the second because the first person would have already been chosen, and then times 1 for the third person. Then if I multiply all those together, I get 6 different ways I could arrange the 3 people to be in a line. This idea is what's known as factorial. Okay, so it's an exclamation point. You want to be able to find that button on your calculator. Whatever type of calculator you have, just Google search like factorial with that calculator, and you should be able to find it. There's probably some probability button somewhere on your calculator or some secondary feature. If you're having trouble with that, please send a picture of your calculator and can help kind of troubleshoot where that would be. But you want to be able to find the factorial. So factorial essentially is arrangement of items. So if I say there's 10 people, it's 10 times 9 times 8 times 7 times 6 times 5, etc., all the way down to 1. The problem is that takes a really long time to plug in to a calculator, so you can just rearrange it and say, okay, well, I'm just going to do 10 factorial, and that does that for you. One side note that might be helpful is to know that 0 factorial is 1. It's not 0. That's important when you start using formulas for permutation combination. Probably less important with the factorial rule itself, but it's just decreasing the order all the way down to 1 to find that answer. The next thing we're looking at is there's 28 cities in the U.S. that I would like to visit. Okay, how many different routes could I take if I want to visit 4 of them? So now the first thing to notice is the order matters. So a route would be different depending on which way you go. But this time I'm not doing 28 factorial because I don't want to go visit all 28 cities. I only want to visit 4 cities. So what I like to do here is, again, I have 4 spots to fill in. And I'm going to start with 28 because there were 28 cities to choose from. And then 27, 26, 25. If it said you could repeat the cities, then that would change the numbers. But this is assuming no repetition after I've been to the city. I'm going to move on to another city. And that's why it would be 28, 27, 26, 25. And there's just under 500,000 options. So a lot of times when we're trying to plan like a family trip or something, I kind of joke around and say, well, just give me a little bit of time because I've got 500,000 options to pick from. Now, most of the time that's eliminated by a lot when I say, well, which way do we want to go? Do you want to go north, south, east, or west? And that eliminates a lot of the options and makes 28 maybe down to 7, for example. But this stops at the 25, and so it's only those four numbers that you multiply together. This is the example of what's known as a permutation. A permutation says the order matters and the arrangement of those items. So for example, like here at the bottom, ABC is different than CBA. That's the idea of the route. Okay, the notation here is always n number of items, and then you're choosing or picking r items out of it without replacement. Okay, so permutation, order matters, there's n total amount, and you're choosing or picking r amount out of that. The way that we write this is 3 ways to write it. Okay, if you've taken an Algebra 2 class that dealt with some probability, you've probably seen a formula like this before. Our focus is going to be less on the formula itself rather than letting technology kind of find the answers as we move through some of those questions. So for these scenarios, it's NPR, okay, so number of items, picking, and then how many you're choosing out of that group. You could also write it like this middle version, which might be the easiest with technology to write. So if you're trying to type something out, this would be the easiest option. And then the formula comes from this idea right here, and we'll look at that, n factorial over n minus r factorial, and that's what your calculator will go through to find that answer. So let's go back to the 28 cities question. Okay, we already know the answer should be this 491,400 number. I have 28 cities that are there. I'm choosing or picking 4 of them. So that's N and R. I can write that 28 permutation 4, or P for permutation of 28 comma 4, and that's represented by 28 factorial over 28 minus 4 factorial. Now here's what really happens. When it's 28 factorial over 4 factorial, think about it. 28 factorial is 28 times 27, 26, 25, 24, 23, etc., all the way down to 1. The bottom is 24 factorial, which would be 24 all the way down to 1. So what happens is 24 all the way down to 1 cancel out, and you're left with 28 times 27 times 26 times 25, which is what we did already without knowing the permutation idea, because there were only 4 locations we had to fill. So for this scenario, I've got N is 28, R is 4, and I can plug that in. There should be a way on your calculator to find that number. What's going to be important for our class is that you show me the setup, and the setup can be in any of these 3 options. To be honest, probably the middle one's the easiest to show on a computer. Any of these first 2 are easiest to show on paper. Your book's going to focus on the last one because that's how you find the number, but I need you to be able to at least set it up, and then we'll plug in and find that answer. So make sure you try that to see if you can get that using the NPR button. It's probably an NPR button on your calculator, either in a probability section or a secondary feature on it. The next thing to discuss is what's known as the permutation rule that deals with identical items. This is the idea of arrangement of items, but some of them are the same. And so what we have to do is count, like if I switch the 2 and it doesn't do anything, I need to get rid of those ideas. And honestly, I think it's probably easiest to show with an example here, which we'll look at in a moment. But it's the number of ways to arrange the item, which would be n factorial, and then divide by how many times factorial those things repeat themselves. So let's look at the arrangement of the letters in a word. Now you have to think password here. We're not looking for like specific words that actually make sense in our language, okay, that we're using, whatever language it is. Okay, you can do this in any version. But we're just looking at arrangements password style. So the letters OK, that's 2 factorial because there's 2 letters. Then I just look at how many versions of each letter there are. So for the letter O, there's 1, so that's 1 factorial. For the letter K, there's 1, so that's 1 factorial. And 2 factorial is 2 times 1, which is 2. Divided by 1 isn't going to do anything. And actually what you'll notice is when we get further along here, I probably won't be showing the equal or the 1 factorials very often as I'm looking at those scenarios. The word math has 4 letters, so that's 4 factorial ways to arrange them. And I just divide by 1 factorial a bunch of times for 1m, 1a, 1t, and 1h. But again, that's not going to do anything. And so 4 factorial is 24 because 4 times 3 times 2 times 1. The next one is the word Purdue. Now there's 6 letters in the word Purdue, so that's 6 factorial. Now notice I didn't put any of the ones for, there's only 1 P, 1 R, 1 D, and 1 E. But what you want to notice is if you switch the U's, that's the same exact password. And so I have to divide by 2 factorial because there's 2 U's that I need to take care of, and that will give me 360. Mississippi has 11 letters, so that's 11 factorial. There's 4 I's, 4 S's, and 2 P's. And so I need to divide by 4 factorial, 2 factorial, for the way to arrange the S's, to arrange the I's, and to arrange the P's. You want to make sure you try that question on a calculator. Most likely you need to put the division of those factorials on the bottom in parentheses. So I would probably plug it in 11 factorial, divide by parenthesis 4 factorial, 2 factorial, end the parenthesis, and that should get your answer for the 34,650 as you're looking at those situations. The combination rule is similar to permutation. It's ways to order things, ways to choose things, but the order doesn't matter. So it's still n different items. You're choosing r of them, but without replacement. But now it doesn't matter the arrangement of them. So the formula here is just instead of NPR, it's NCR, which would be combination of n choose r. You'll notice there's this third notation that kind of looks like a fraction, but there's no fraction bar. I'll try to mix and match what we're looking at here. But when we are dealing with those and I'm writing stuff, it's probably that situation. And this formula here on the right side is the same as the permutation, except there's an extra r factorial as you're looking at that question. So just realize that it's combination if the order doesn't matter for that situation. Okay, so here's an example of that. There's 18 candidates for a 4-person board. How many different ways can the board be selected? Now, it doesn't matter if you were first selected or third selected on the board. You're just on the board of trustees or you're not. So there's n is 18 because there's 18 candidates. Choose 4 because there's 4 people for the board. And that would be 18 choose 4 or combination of 18 choose 4, 18 and 4 as this kind of, it looks like kind of like a fraction, but that's the notation that you can use for that. And then 18 factorial over 18 minus 4 factorial and 4 factorial for the 4 ways to choose that. You should probably focus on one of these 3 ways of writing it, but you need to plug in with the NCR button to find this answer of 3060. So when you're dealing with these questions, you want to make sure that you can plug in the numbers appropriately. Make sure you can show me a setup, even if it's just one of these 3 things, and then let the calculator do the work at this point. We're going to do a lot less of the distribute or canceling out idea if you've done that in Algebra 2, because you've already shown you can do that. And I want to make sure we can move on to some more complicated questions. And so we're just going to set them up, show me the setup, and then find the answer, and that'll be enough for what we need for the question. Have a good day, everyone.